like I said earlier, I have my book. And I have my notebook from class, which I have from, well, these pages to copy over. So I go over here. I'm actually on this page. I'm at this is really bad handwriting, which is another reason why I rewrite it. Just so that, like, if I ever need my notes later on and I want to be able to understand them, I can have something a little more understandable. So, this is just my cheap notebook, staples, and I'm at fatty acids, so I go to the book here, and I read about fatty acids all the way till here, and then usually, like, on the next page of my notes, I'll have that subtitle, like, nomenclature, because she usually goes with the book, for the most part. The last test we had, she was all over the place in the longest chapter of the book, and I was just so frustrated with it. I ended up getting 80, like 89 on the test, so not too bad. Or no, an 85, sorry. I can't remember. I seem to not be able to get out of the B range in this class. So that way I do that, look at my notes, read, and then I take those notes and rewrite them in this notebook in a neater fashion. I have them marked, like, right here. I did not copy the notes from the very first part of class because that was just stuff that we've been learning since, like, legit 7th grade, just the structure of the cell. So I figured I didn't really need to redo that. But anyway, I have gone over the basic introduction. So now we're learning about fatty acids. So my notes say that a fatty acid is the simplest lipid. It's a hydrocarbon chain with a carboxylic acid group. It's polar, hydrophilic. It has a hydrophilic and hydrophobic end, and it's not soluble in water. And then it also says the corresponding page of the figure. So I go to my book and I read that as a class, the fatty acids are the simplest of lipids. They are composed of straight hydrocarbon chain terminating with a carboxylic acid group. So that's one thing that my notes don't say, is that it's a straight hydrocarbon chain with a carboxylic acid group, but the book tells me that it ends with a carboxylic acid group. It's not like anywhere in there, it's just at the end. Fatty acids, therefore fatty acids have a polar hydrophilic end and a non-polar hydrophobic end that is insoluble in water. Fatty acids are components of the more complex lipids discussed later in the sections. They are the vital importance of energy nutrient, furnishing most calories derived from dietary fat. And it's just like a pain in the ass to keep going back and forth, but it's the only way I learn. The lengths of the carbon chain of fatty acids found in fluids and body tissues vary from 4 to 24 carbon atoms. The fatty acids may be saturated, monounsaturated, or polyunsaturated. So SFA, MUFA, or PUFA. Don't question it. PUFAs of nutritional interest may have as many as 6 double bonds where a carbon-carbon double bond exists. And there is an opportunity for either cis or trans geometric isomerism. And I have no idea what any of this means usually, so significantly affects the molecular configuration of the molecule. A cis isomerism form results in the folding back and kinking of the molecule into a U-like, I can't see that, orientation, whereas the trans form has the effect of extending the molecule into a linear shape similar to that of a saturated fatty acid, which is not good. The structures in figure 5.1 illustrate saturation and unsaturation in an 18-carbon fatty acid and show how cis or trans isomerization affects the molecular configuration. So, what does this say? Saturated and unsaturated. So this is let's see. Alright, yeah, that makes sense. Okay, so I can start copying that down. So we start with fatty acid as the title. It is the simplest lipid. It's a straight hydrocarbon chain. Ending with a carboxylic acid group. Alright, and so there we have a polar hydrophilic and a non-polar hydrophobic. Non-soluble in water. They have carbon chain lengths from 4 to 24 carbons. There's saturated fat, which which is abbreviated SFA. There's no carbon-to-carbon double bonds. I'm going to read more from the book. The more carbon-carbon double bonds occurring within a chain, the more pronounced is the bending effect. The degree of bending plays an important role in the structure and function of the cell membrane. Most naturally occurring unsaturated fatty acids of the cis configuration Most naturally occurring unsaturated fatty acids of the cis configuration, although the trans form does appear in some natural fats and oils, and in dairy products and beef. Trans fatty acids are produced by ruminant bacteria. Most trans fatty acids are derived from partially hydrogenated fats and oils. So, margarine is an example of a trans fat, or something that contains trans fat. I wonder if these have any. No, these don't have any fat, which would make sense. I shouldn't have put my cheese next to my computer because it's really hot. There. So there's probably some trans fats in here, which aren't good for you because they have like saturated fats, which are bad for you. Partial hydrogenation is a process commonly used in making margarine and frying oils. It's designed to solidify vegetable oils at room temperature. Double bonds of cis orientation that are not reduced in this process undergo an electronic rearrangement to the trans form, which is energetically more stable. The availability of trans fatty acids in the typical U.S. diet has been estimated to be approximately 8.1 grams per person per day. Its major source being margarines and spreads. More recent quantitative estimates are not available, but the requirement to list the amount of trans fatty acids on food labels should result in reduced consumption. Concerns have been raised about the possible adverse nutritional effects of dietary trans fatty acids, particularly their role in the etiology of cardiovascular disease. This topic is discussed in the section Lipids, lipoproteins, and cardiovascular disease risk later in the chapter. So we'll continue on with copying notes. And because we've reached the next subtitle. So, monounsaturated. Or MUFA. Have one carbon-to-carbon double bond. And polyunsaturated. or PUFA. Such a weird name. Have 2 or more carbon-to-carbon double bonds. I have green on my finger already. And I think I can put the last thing, which is, they have scissor trans configuration. There we go. Okay. And I like to go through, actually, and it doesn't really serve any purpose other than the fact that it makes it look like I've actually accomplished something. And check off each section that I've done. I should have written this one on the next page. I love these pens, the way they write, but they don't dry very fast on the sheet, so it gets all over my fingers. Alright, so scissor trans configuration. Trans fatty acids behave more like saturated. Let's see. Trans fatty acids are naturally occurring. I often switch from holding my pen like this to this, just to change it because my hands get tired. Naturally occurring in beef. And in dairy products. It also occurs from food processing. By hydrogenation. So when you see like partially hydrogenated vegetable oil or stuff, it's not necessarily a good thing. It adds hydrogens to the carbons of unsaturated fatty acids. Examples are Crisco and margarine. Okay. We are moving on to nomenclature. I don't know what that says. Okay, let's go to the book. Let this ink dry. So, let's see. Two systems of notation have been developed to provide a shorthand way to indicate the chemical structure. Oh, okay, now I know what that says. I remember from class now. Excuse me. Both systems are used regularly and will be used interchangeably in the text for different purposes. The delta system of notation has been established to denote the chain length of the fatty acids and the number and position of any double bonds that may be present. For example, the notation 18:2 delta 9, 12 describes linoleic acid. The first number, 18, in this case, represents the number of carbon atoms. The number following represents lost my spot. The first number, 18, in this case, represents the number of carbon atoms. The number following the colon refers to the total number of double bonds present. And the superscript numbers following the delta symbol designate the carbon atoms at which the double bond begins. In this system, the number starts from the carboxyl end of the fatty acid, so it'll start at the end of it and not the beginning of it. The second commonly used notation locates the position of the double bonds on carbon atoms counted from the methyl or omega end of the carbon chain. For instance, the notation for linoleic acid would be 18:2 omega 6. Substitution for the omega symbol with the letter N has been popularized. I don't know why they wouldn't use W, because W looks like omega, but anyway. Using this designation, the notation for linoleic acid would be expressed 18:2 and 6. In this system, the total number of carbon atoms in the chain is given by the first number. The double bond is given by the number following the colon. The location of the first double bond is given by the number following omega or N. The system of notation takes into account the fact that double bonds in a fatty acid are always positioned so they are separated by 3 carbons. Thus, if you know the total number of double bonds and the location of the first relative to either the methyl or the carboxylic end, you can determine locations of the remaining double bonds. I did not know that. Did not. Interesting. See, I like to read this because it makes sense, even though my notes don't include everything, every little detail from the book, which is good because I don't need to memorize everything, but reading it puts it into perspective, which is important, and if you want to learn and kind of somewhat remember it. Okay. Coffee. Probably cold by now. Yeah. just by chain link. Number and position of the double bonds. So, an example would be linoleic acid, which is 18 carbons long. There's 2 double bonds, and they're located, delta, located at 12. So, I can fix my delta sign here. So, linoleic acid has 18 bonds. Sorry, 18 carbons. It is an 18 carbon chain. Is separated by the colon, and then has 2 double bonds. And this is the Greek delta, which means that it's showing that these 2 double bonds noted here are located at the 9th and 12th carbon on the chain. And I can show it to you. No, I can't, because I don't have a picture of it. I actually can draw it for you. Sorry guys, I know it's really loud. Sorry. This is gonna be a really crappy drawing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's really bad drawing. This is the carboxylic end over here. So you count. Here, you count from this end down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a double bond. 10, 11, 12, and there's another double bond. 18:2 N6 doesn't give you location. All bonds. And this has to look at figure 5 too. Which doesn't really help me much at all, because I already know this part. So, let's try. I'm gonna turn the page. These don't. Let me find. This is going to be about fatty acids and their states at the room temperature. Ooh, that was loud. Because, as you know, different fats have different consistencies. Like oils are liquid and butter is solid. So, no, excuse me, depending on what kind of fatty acid it is. Depends on what it is at room temperature. So, I'm not sure if this is in the book or not. It might be out of order. Yeah, so this is what it sucks. And you just kind of have to write down and make yourself understand it. Okay, so fatty acid states at room temperature. Saturated fats first. And we're going to start with long chain saturated. Long chain saturated fatty acids are solid at room temperature. And medium / short chain are soft to liquid. Next is monounsaturated. And those are liquid at room temperature. Polyunsaturated are also liquid at room temperature. And are essential fatty acids, which are omega-3 and omega-6. You know what? This might actually be in the book, so I'm gonna look at it again after I'm done writing down the essential fatty acids. Omega-3 is liquid. nothing in here about room temperature. Let's see. We'll read about essential fatty acids. If fat is entirely excluded from the diet of humans, a condition develops that is characterized by retarded growth, dermatitis, kidney lesions, and early death. Studies have shown that eating certain unsaturated fatty acids such as linoleic, alpha-linolenic, and arachidonic acids is effective in curing the conditions related to the lack of these fatty acids. Two unsaturated fatty acids cannot be synthesized in animal cells but must be acquired from the diet from plant foods. These two essential fatty acids are linoleic acid and alpha-linolenic acid. From linoleic acid, gamma-linolenic and arachidonic acids from linoleic acid, whatever. If you take linoleic acid, the other two can be formed in the body. An intermediate fatty acid in the pathway is something that I can't even pronounce. Eicosanoic. There's an abbreviation for that. I just don't know what it is. The pathway. And then the linoleic and linolenic acids are essential because humans lack enzymes called delta 12 and delta 15 desaturases, which incorporate double bonds at these positions. These enzymes are found only in plants. Humans are incapable of forming double bonds beyond delta 9. In the chain, if a delta 9-12 fatty acid is obtained in the diet, however, additional double bonds can be incorporated at delta 6, which is desaturation. Don't know what that means either. Fatty acids can also be elongated by the enzymatic addition of 2 carbons at the carboxylic end of the chain. These reactions are discussed further in another section of this chapter. Essential fatty acids. I really wish I had a desk to do this at, but I don't. So I'm stuck here with really crappy hip joints and it hurts. Okay, so essential fatty acids. 2 polyunsaturated fatty acids we can't make. Sources of those 2. That's it. Okay. See, like that. That section is way longer than it needed to be. Because she just wanted the basic information from the first couple sentences, and that was it. So, we have 2 polyunsaturated fatty acids. Humans can't make. They are called alpha-linolenic, which is otherwise known omega-3, And I'm going to condense some of these notes. Some sources would be cold water fish, and walnuts, flaxseed. The other one is linoleic, or omega-6. And the sources are beef and poultry, Did the book just not tell us that we couldn't get any of these fats from any animal source whatsoever and we had to get it from plants? But the sources are from fish, beef, and poultry. I don't understand. Oh well. So, I think I'm gonna end this video here because I need to get up and stretch my legs before continuing on. So I have a lot more to do. So, I know this video was really